That is class 16, right?
Yes, sir.
So we have seen the design of electro dynamometer, ammeter. Electrodynamometer type voltmeter. So here the theta is proportional to square of the RMS current. Here the theta is proportional to square of the RMS voltage to be measured. Both are going to have non-uniform scale like your moving iron. Okay. Then the core structure of this consisting of shortly fixed coils divided into two halves. Okay. One moving coil. As per the principle, this is your current I1 of T. So need not to put the polarity marking. Fixed coil, fixed coil. Here we have the moving coil. Excited by current I2 of T. Refer the dot connection for the circuit. With this, the pointer is attached. That is giving you the deflection over the scale. Goes on. Okay. That's your moving coil made up of some N1 number of turns. Total, this is N1 by 2 we can take. This is N1 by 2 we can take. And this is N2 turns moving coil. Okay, fine. So what is the theta of T? Deflection of the pointer. Theta of T, angular displacement. This is the displacement already happened. That's your displacement happened. Theta. Okay. Yes, what's the displacement theta? The basic equation governing this electrodynamometer type instrument. Theta of T. Theta of T, please. 1 by K into dm by d theta. That's your constant of the meter into I1 of T into I2 of T. Getting all of you?
Yes,
Or
sir.
at least remember the TD of T. With that you can manage. TD of T is what? dm by d theta into I1 into I2 of T. Getting all of you? Yes. Yes, right? Yes or no?
Yes, sir.
So from this only we got theta of T. So then we made I1 equal to I2 as I. Then we got electrodynamometer ammeter. Then we made that I. So we made I of T is equal to what? I1 of T. That is equal to I2 of T. Then we got this result. Then if I of T is made function of your V of T divided by the resistance, discarding the meter currents, meter resistance and all, total resistance of the instrument or total impedance of the instrument, then we can convert. So we can convert the voltage to be measured into current by connecting suitable voltage bypassing resistor, a series resistor or multiplying resistor. Then we can make the deflection proportional to the voltage, but actually the instrument converts the voltage into current and current is converted into Dynamometer, voltmeter, voltage converted to current. Current converted to what? Theta. That's how it is done. Understood? Because it is fundamentally this is also a meter. Understood? Like moving iron, this electrodynamometer instrument is also a meter because there are two coils, both are current sensing coils. Understood? If you are converting that into potential coils, that is voltage sensing coil, then you need to have a suitable resistor. Understood?
Yes, sir.
Yes or no? So you can put them in series. Arrangement is already given. So connect all the three coils together, but in such a way that you get the aiding flux, okay, for the moving coil as well as fixed coil. Aiding flux is important. A wrong wiring, definitely the deflection will be negative instead of positive deflection. Understood? So proper connection should be made between the fixed coils and moving coils when they are connected in series to make an ammeter. And the same setup with extra resistance R series can be configured as a voltmeter. Understood? But unfortunately, both resulted in non-linear deflection of the pointer because theta proportional to I square RMS at steady state and theta also proportional to V square RMS at steady state in ammeters and voltmeters. So that's a conclusion we made till now. Understood? Yes or no?
Sir,
Yes, Rahul.
Yes.
sir, when we're saying I1 of t equals to I2 of t,
Yes.
how is the connection is made, sir? Like that moving coil is separately excited, or all the
Already
three
given,
coils
right?
are in series? Like
All are in series. Already
yes,
setup
sir.
is given, right? Forget.
All are in. Yeah, no, sir. That's what's my doubt, sir.
Okay. Already
From
shown.
the
We have
last
designed
circuit
it.
diagram.
We have
Yes,
designed it. I'll show that.
yes, sir.
I'll show that.
Okay. All the three coils were in series.
Should be in series.
Okay.
But still they have to produce aiding flux. Getting? All of you?
Yes, sir.
Getting, Rahul?
Okay, sir.
Understood?
Yes, I understood, sir.
Okay.
Before, okay, I understood, sir. Yeah.
If you swap this connection, then you'll be in trouble. Negative deflection it will create. Moving coil connection, feed it to
Yes, sir.
the
No, sir.
right
I
side
thought.
and then,
Uh,
yes. Yes, what is your idea?
yes, sir. I think so. There's some lag actually.
Okay, okay.
Uh,
Got it now?
I think. Yes, sir. But what I thought was the moving coil is separately excited with the same I of t.
What it mean?
I thought like that. Like
What it mean?
no,
See, you have only
how?
one current. How we can go for two different excitation?
Yes, sir.
Okay. Then
Okay.
how we can pass the current? Because it's a current
So
sensing instrument. Then it has to be in series, right? So
yes,
tell me
sir.
how you connect the moving coil then? How
Okay.
we will connect the moving coil
Yes,
to
sir.
sense
Got
the
it,
same
sir.
current then? If we connect it in
The
parallel, that
moving
I
coil
of t
will be
will get
connected
divided,
to.
right?
Yes, sir. Got it, sir.
Suppose by mistake, if we connect
Okay,
moving
fine,
coil
sir.
in parallel with the fixed coil, current division takes place between fixed
Mm.
coil and moving coil. Then how I1 can be made
Yeah.
equal to
Okay.
I2? The moment I say that two currents are equal and your coils must be connected in series. Understood?
Yes, I got it. Okay.
Only in
Yes,
series
sir. Yes, sir.
circuit, current through the elements are identical. Understood?
Oh, yes, sir. Okay, sir.
Sir.
Okay, simple logic.
Sir,
Yes.
sir, always in electrodynamometer, I1 of t equal to I2 of t, sir.
See the heading given, Monopriya? What is the heading, Monopriya?
Ammeter.
Yes, only in ammeter it is the
Electrodynamometer.
case. Okay.
Oh,
But
okay.
general configuration, we don't go like that. So this is your general configuration. This is your general configuration. You have to have four terminals actually. Two terminals for your current that is your fixed coil. Another one is two terminals for the moving coil. Getting? Understood?
Yes, sir.
Sir.
An electrodynamometer instrument is actually having four terminals. Okay, if it
Okay,
is
sir.
designed as an ammeter, you have only two terminals. Suppose it
Okay.
is having four terminals, you are asked to make it an ammeter which is having two terminals, then you need to make the external connection. Getting everyone? Yes or no?
Okay, sir.
Okay, because it is
Okay,
internal to the instrument. Fixed coil, 2 terminals will be there. Moving coil, 2 terminals will be there. Simply connect them in series. Nothing wrong.
okay, sir.
Okay, so that means how you can make the connection physically is, so the fixed coil only 2 terminals will be there. Then you bring the moving coil connection. Okay, so
Yes,
something like this you can connect. Nothing wrong. The result is same. If it is externally, okay, if we have external connection, then you can make something like this.
yes, sir.
Okay, physically,
Then,
yes,
then
physically,
for what they are giving that 4 terminals, sir, where it is used, sir?
we'll see.
When
It's
we
not
give
over.
to,
It is not over,
okay, sir.
Monopriya. Okay,
Okay, sir.
there is
Okay, sir.
lot more to come. Okay, right?
Okay,
So
sir.
then this is your fixed coil. Okay, this is your fixed coil. Shortly, let me say fixed coil, and this is your moving coil. Okay, having two wires. Assuming this is how you have the terminals, this is your current passing, and
Okay,
this
sir.
is your return current. Let me take I of t. What you can do is you can pass the current from here to here also, I of t. Then you can take the current this way also. Getting Rahul? This is also fine, nothing wrong. If the designer is
Okay,
willing
sir.
to, is willing to give you some confusion, he may connect this like this. Okay, but finally you need to conclude
Okay.
it is same current going through fixed coil and what?
All are included.
Moving coil.
Yes,
Okay.
sir. Yes, sir.
Reason is when it comes as an
Yes, sir.
instrument, it can't make the middle connection. All of you getting? All, able
Okay,
to
sir.
follow me?
Yes, sir.
Only
Yes,
these
sir.
4 terminals are available for you. Okay. These are the 2 terminals of your fixed coil. These are the 2 terminals of your moving coil. All of you getting?
Yes, sir.
Then
Yes,
how
sir.
to make the external connection then? Either you have to make the external connection like this. Okay, so this is your I of t. This is your external connection. Then you can connect like this. Then you can take like this. Getting?
Yes, sir.
All of you. Are you happy? You don't see any twisting. Rahul,
Yes,
are
sir.
you happy? They might have
Yes,
already
sir.
mentioned this is plus, this is minus, this is plus, and this is minus. Tell me what mistake you committed. Understood?
It will rotate like this. Okay.
Understood?
Yes, sir.
Understood now. Reason
Yes,
this
sir.
will be north, south. This will be south. This will be north.
South.
Okay, understood. So
Yes,
repulsion,
sir.
it will move down, and this is north, south. What will happen? This will repel. Getting? So instead of pointer positive deflecting, it will start negative deflecting. Yes, anyway, physically that's how we need to see. When the pointer deflects negatively, simply interchange the connection. Getting? All of you?
Yes, sir.
Yes, sir.
That's all. Okay, any 2 wire you change the connection, then automatically you will get positive deflection. Yes. Yes, we are going to
Okay,
do
sir.
this in the next application once again. Okay, so you're getting the idea for that now itself. Therefore, it has to be connected here because current should enter the positive terminal. Then it will become,
Not, sir.
north.
Not.
Understood, everyone? Then it will become south. Then it will create positive
Yes, sir.
deflection. Okay, yes. So then it has to be the wire coming out. Yes, refer the dot connection. That's your I of t. That's a connection, physical connection. Okay, understood? For a meter. Getting?
Yes, sir.
If only the
Yes.
knobs are given externally, because your fixed coils are internal, you can't divide in the middle and then make the connection. So therefore, keep the fixed only for understanding purpose. It is connected that way. Okay, this is the physical ammeter connection. Understood? 2 terminals of fixed coil available externally, 2 terminals of the moving coil available externally. Your job is to make the fixed coil current passing through the moving coil current without the polarity. Yes, polarity making important, polarity marking important or not? Yes or no?
Yes, sir.
Yes, sir.
You are not exciting by DC, you are exciting by AC, but you should know what is plus, what is minus. Accordingly, plus terminal current should enter, minus terminal current should leave. Understood? Or you make, that means if your plus is serving as a phase, everywhere it is a phase. If the plus is serving as a neutral, everywhere the plus is serving as a neutral. Understood? Understood?
Sir.
Okay. So interchanging this as phase and neutral, or this as neutral or phase, not an issue. The result is still positive deflection. Understood? All of you getting?
Yes, sir.
Okay.
Sir,
Yes.
Yes. Dharmasha.
for ammeter, everything should be connected in series, sir. So for voltmeter, the 4 terminals can be.
Ammeter, what once designed right? Ammeter.
Yes, sir.
Then put a series resistance. That's all your voltmeter is.
Okay, sir.
Got it?
Yes, sir.
Okay. Yes. Getting everyone? Voltmeter you need to connect a series resistance. That's all.
Yes, sir. Getting.
Once ammeter is designed, after that you are converting ammeter into voltmeter. What do you need extra? Or series.
Okay, sir.
Okay. Getting then
Yes.
Vasha.
Yes, sir.
Okay. So that's how we can convert your ammeter into voltmeter. That's the same basic step which you already understood in the PMMC. You already understood in the moving iron. Doing it again once again. Okay. All of you getting?
Yes, sir. Sir, electrodynamometer needs swamping resistor, sir, to compensate temperature.
Moving iron needs, right?
Yes, sir.
Then all the instruments, overall current sensing, definitely we need them.
Okay, sir.
Okay.
Yes, sir.
Understood? Depending on the application also, whether it is configured as an ammeter, voltmeter, depending on that. Okay. When moving iron needs, definitely electrodynamometer also needs. Understood?
Okay. Yes, sir.
Whenever a resistance variation of the coil happens, then swamping resistance always, with respect to the change in temperature, that makes a significant error in the instrument. Swamping resistor, it is mandatory. Getting Monopriya?
Yes, getting. Sir.
Okay, yes. Next application we'll see. Current I of T passing through the fixed coils. That's a moving coil. Excited by a series resistor, excited by a voltage source. So you have a series resistance. R series that is very, very greater than the moving coil resistance. Okay. Not only that, okay, the moving coil is the impedance of the moving coil circuit, the total impedance of the moving coil circuit, this impedance. If we talk about this impedance, is that this impedance is highly resistive. This impedance is highly resistive. What does it mean? What is the total impedance actually? You'll get R series plus RMC plus SLMC you will get as the impedance. Getting everyone? Yes or no?
Yes, sir.
So I'm saying that R
Yes,
series
sir.
is such that, so this component, this contribution, okay, this contribution is little comparing to this contribution. R series plus RMC is dominant comparing to this. If that is the case, tell me what's the phase angle of this? What is the phase angle of this? Current going through the moving coil. That's a current going through the moving coil. I moving coil current. And this is I fixed coil current. Fixed coil current is equal to I of T. And here moving coil now exciting by a voltage V of T. But I moving coil current is in phase with V of T. That's what I want. In phase with V of T. All of you getting?
Yes, sir.
So to make moving coil current in phase with the voltage applied to the moving coil, so I need to make it purely resistive. Then only they will be in phase. Agree all of you?
Yes, sir.
So then let
Yes,
the
sir.
moving coil circuitry is purely resistive. That's what it means. Or highly resistive. So that the reactance of the moving coil circuit is negligible comparing to the resistance. Therefore, treat this as a highly resistive or purely resistive. Highly resistive or purely resistive, so that moving coil current is in phase with the voltage applied or exciting the moving coil. So for namesake, let me take the polarity marking. This is plus minus, and this is also what? Plus minus. Understood? Namesake. It's not a DC instrument. Namesake to represent phase and neutral. Okay, right? Understood, everyone? Yes or no? Following this or not?
Yes, sir.
Yes, sir.
Now tell me what's the deflection of the pointer, theta of t. What is theta of t? Proportional to what? Theta proportional to what? Theta is proportional to the two current. One is the fixed coil current and another one is what? Moving coil current. Understood?
IM.
I1 and I2. Shortly we
Moving
called
coil.
earlier. Now make it okay with the suffix FC, fixed coil, MC, moving coil. What is the fixed coil current? Fixed coil is sensing what? Fixed coil current is proportional to what? The current I of t. And moving coil current is proportional to what? The voltage applied. All of you getting? Yes or no? Yes or no?
Yes, sir.
Yes,
Because
sir.
what is the moving coil current? Because it's purely resistive circuit, voltage is converted into what? Current. That current is going through that. Therefore, who makes a current through the moving coil? Only the voltage. So proportionality is V of t. All of you getting? All of you getting this?
Yes, sir.
Okay. Now tell me, what is theta of t of the instrument? Theta of t, perfect theta of t of the instrument. Or okay, theta of t of the instrument. Deflection, steady state deflection or instantaneous deflection. What is that? 1 by k into
1 by K
dm by d theta
dm by
d
dt.
theta into what? I1 of t. That's a fixed coil current. I2 of t. What is that? Moving coil current. Then theta of t, I can say what? 1 by k into dm by d theta. Getting everyone? What is I1? I1 is I of t. And I2 V of t divided by your R series alone. Let me consider. Assuming the R series is very, very greater than rest of the moving coil impedance. Understood?
Yes, sir.
Yes or no? Yes. Then tell me what is your theta of t. Then theta of t is equal to 1 by k into dm by d theta into 1 by R series. Okay. Then what is the rest? I of t into V of t. Tell me what is V of t into I of t.
Power.
What power?
Instantaneous power.
Instantaneous power. If I of t is periodic, V of t is also periodic, then tell me what is the average deflection of your pointer. Then theta average is going to be 1 by k into dm by d theta into 1 by R series. Okay. That's how you're going to get the deflection. Then it is 1 by t integration 0 to t. Then you will get p of t into what? dt. That's the shortest way to prove how the instrument is going to deflect. So what is that? What is this one? What is this one? What is this one?
Average power.
Yes. Therefore, what is theta average then? Theta average, then take entire thing as a meter constant, km, and into what? Average power. What did it mean? What did it mean?
Treats average power.
Yes, electro dynamometer. What? As a what? What instrument?
Voltmeter.
What meter?
Watt meter.
Yes. When you want to use both the coils, that's a question, Monopriya. So now you have to excite your fixed coil by the current of the load, excite the moving coil by voltage of the load, where you want to measure the power. Then you can measure the average power delivered to the load by using electrodynamometer type instrument. What's the beauty of the instrument? What's the beauty of the instrument? theta average is proportional to power average. It's not proportional to the square of the average power. Therefore,
Uniform scale.
electrodynamometer will offer very uniform scale
Uniform scale.
because it's proportional to the power to be measured. So that's why we never use electrodynamometer wattmeter for meter for ammeter or voltmeter. Always we prefer to use electrodynamometer as a wattmeter. Getting everyone?
Yes, sir.
It is going to offer very uniform deflection. Due to that, we get very uniform scale. If the deflection is uniform, the scale is uniform because deflection only calibrated into the wattmeter reading. The power reading, okay, which is in watts, okay. Deflection only calibrated in terms of parameter being sensed or measured. So this is going to result in very uniform scale, unlike our moving iron ammeter, which is non-uniform scale, and electrodynamometer ammeter non-uniform scale, and electrodynamometer voltmeter also what? Non-uniform scale. Understood everyone? Getting the
Yes,
point?
sir.
Yes, sir.
Okay, so this is the
Yes, sir.
shortest way, okay, how we can configure, to show how we can configure a electrodynamometer instrument as a wattmeter. So this is electrodynamometer instrument, or shortly let me say EMMC as a wattmeter. Getting everyone?
Yes, sir.
As a
Sir,
watt.
ammeter, voltmeter, and wattmeter all have different scales, sir.
Yes, definitely, because already you got non-uniform. You cannot configure. See, with one instrument, you can't make all. See, the instrument
Okay,
is
sir.
basic monopriya. It's
Okay,
your
sir.
job to configure that as an ammeter. Then you have to use it only as an ammeter. At the same
Okay, sir.
time, this instrument can be configured as an ammeter, voltmeter means not possible because for ammeter, it's a non-uniform scale.
Okay, sir.
For wattmeter, it's a uniform scale. Understood?
Okay, okay, sir.
Design is unique. Ammeter design is unique. Voltmeter design is unique. Wattmeter design is unique. But the basic behind the instrument remains same. Understood, everyone?
Okay, sir.
What are
Yes,
the
sir.
extra you are connecting when you configure the instrument as a wattmeter? You need to connect a high resistance in series with the moving coil.
Okay, sir.
Yes or no? All of
Yes,
you
sir.
getting? All of you
Yes,
getting this
sir.
point? Yes, Nirmala getting this point?
Yes, sir.
Then you need not to call this as FC hereafter. You can happily call it as CC. And this is CC. And this is what? PC. What it mean? These two coils are sensing the current, okay, of the load, and this coil, the moving coil, is sensing the voltage of the load. Okay, with this only we can measure the power of the load. So therefore, the fixed coils are designated as current coils in wattmeter connection, whereas a moving coil is known as a potential coil or what? Pressure coil. All of you getting?
Yes, sir.
Okay, so hereafter, the moment you configure your EMMC instrument as a wattmeter, fixed coil should be called as current coils, whereas the moving coil should be called as a pressure coil or potential coil that is
Potential,
going to
sir.
sense potential of the load whose power is to be measured. We have a load, we want to measure the power of the load. Let the current coil sense current through the load and let the potential coil sense voltage across the load. That's how we need to configure them when we configure EMMC as a wattmeter. Is this clear to everyone?
Yes, sir.
Yes or no?
Yes, sir.
Getting Nirmala?
Yes, sir.
So what is the must condition? What is the must condition?
Current should be in
If we
phase.
want to make a power
Series
measurement
resistance.
properly, the moving coil current should be in phase with the voltage. Understood?
For this purpose only, RSC
Yes.
should be greater than RMC. sir.
Yes, it should be purely resistive. Otherwise, this will create a phase difference. Okay? All of you getting?
Okay.
Now, listen to this. Let the fixed coil current is IFC of T is, for example, I1 by root 2. Sorry, I1 into root 2. RMS current is I1. So let me say I1 into root 2 sine omega t amps, fixed coil current. Assume the moving coil current is that is, this is shortly I1 of t and this is I2 of t. That is equal to I2 into root 2 sine omega t minus 5 amps. Two currents I'm getting. Tell me what is the average deflection of your instrument. I'm taking EMMC. I'm exciting the fixed coil with a current, moving coil also with a current. Now tell me what's average deflection, theta average. What is that? 1 by K into dm by d theta. Getting everyone? Then 1 by T integral 0 to T I1 of T into I2 of T into dt. Agree everyone?
Yes, sir.
Since theta of T is equal to 1 by K into dm by d theta into I1 of T into I2 of T. All of you getting? Now this is the instantaneous deflection. I'm going for the average. So this is anyway the constant. Then the average is applicable only for the product I1, I2. So average of the product I1, I2 over the period 0 to T. Getting everyone? Yes or no?
Yes, sir.
Yes, sir.
Now let us focus only on the integration part. Let us focus only on this. Then we'll come back to this theta average. We'll see what it is. Okay, that's how the instrument is going to respond. Theta average, not theta average. We'll go for the integration alone. 1 by T or 1 by 2 pi, let me take. 1 by 2 pi integration 0 to 2 pi I1 into root 2 sine theta. That is the first current. Instead of omega t, I'm using theta. Then I2 into root 2. I2 is the RMS current. I1 is the RMS current. Understood now? What is I1? RMS. This I1 is what? RMS value of small I1. I2, RMS value of I2. Understood? Yes or no? Capital I1 is RMS value of current 1. Capital I2 is RMS value of small I2. Understood? All of you getting this?
Yes, sir.
Now tell me what you get. So I2 into root 2 into sine theta minus phi. Okay. Into, take it as d theta. Okay. Instead of time, you can play with the theta also. Now tell me what you get. So t is taken as 2 pi. Okay. Omega t is taken as a theta. Okay. Understood? Integration instead of with respect to time, it is with respect to the theta now. Okay. That's a domain change. Now tell me what are the constants? Root 2, 2 will get cancelled. Getting everyone? Yes or no?
Yes, sir.
Then what is the resultant? I1, I2 divided by pi. Getting? Integral 0 to 2 pi. What is the remaining? Sin theta into sin theta minus phi into d theta. So tell me what is sin A, sin B? Or 2 sin A, sin B as per the trigonometry. Two sin A, sin B.
Cos A plus B.
A plus B or A minus B?
A minus B. Cos A minus B minus cos A plus B.
Confirm
Yes,
this.
sir. Yes, sir. Cos A
Cos
minus B minus cos A plus B.
minus cos A plus B. Getting everyone? Yes or no? Then what is sin A, sin B then? Divided by 2. So let that 2 become here. Okay, so next step, it's I1, I2 divided by 2 pi. Integral 0 to 2 pi. Yes, make it first one. What is A? Take this as A. A minus B you are doing. A minus B you are doing. So then take this as A. Okay, and this is B. It's your choice. All of you following me? That is
Yes, sir.
A is theta minus phi. B is theta. Okay, are you getting? Then this becomes cos A minus B. What is that? A minus B. Theta minus phi. Okay. Theta minus phi
Cos phi.
minus theta. Nothing wrong. Okay. Even you can do this.
So cos is even function, sir. Anything.
Yes, yes, yes. Okay, but that's why. To avoid that. Okay, now you do A minus B. Then automatically phi will become positive.
Yes,
Understood? Then what do you get? Cos phi.
Yes, sir.
Understood? 2 is this denominator 2 is
Yes,
already
sir.
taken. Okay, remaining. First I am getting cos A minus B minus of cos A plus B. What is cos A plus B? Cos of 2 theta minus
2
phi
theta
into d theta. So tell me what is
d
the
theta.
resultant? That's your result. That's your result. Now tell me what's the result? I1, I2 divided by 2 pi. So you need to integrate cos phi with respect to d theta. You need to integrate your cos 2 theta minus phi with respect to theta. Then what do you get? Integration of this cos phi into d theta. 2 component. Okay, so first component integration.
Cos
First component integration. Cos
2
phi
pi into
into theta upper
theta.
limit 2 pi, lower limit 0. Correct? Yes or no?
sir.
It is integration 0 to 2 pi cos phi into d theta. But cos phi is a constant out of integration. Therefore, integration of d theta is theta, upper limit 2 pi, lower limit 0. Getting everyone?
Yes, sir.
What about the second term integration? 0 to 2 pi. What is that? Minus anyway there. Cos 2 theta minus phi d theta. What is this? It's a cosine or sinusoidal signal over a period. Always its area is equal to 0. Yes or no? Yes or no?
Yes, sir.
It's one cycle.
Yes, sir.
One cycle, cosine or sine, one cycle. So cosine is going to be like this. Okay, but still you go for one cycle means what's average? What's the area? Net area for one cycle? 0. Sine or cosine. So that won't result in anything. So that's your result. Then tell me what is the final result? What is the final result?
I1, I2 cos phi.
All of you getting? So the integration 1 by t 0 to t I1 of t whatever given into I2 of t into d theta, this average resulting in I1 I2 by 2 pi, then correct, cos phi into apply limits 2 pi minus 0. What do you get? Cos phi into 2 pi you will get. So result
2
is
pi.
cos phi into 2 pi you will get, and 2 pi will get cancel. This becomes what? I1 I2 cos phi. All of you getting?
Yes, sir.
I1 is RMS value of the current going through the fixed coil. I2 is RMS value of the current going through the moving coil. All of you getting? Yes or no?
Yes, sir.
So what is your conclusion then? What is your theta average then? Theta average is equal to 1 by k into dm by d theta into this component. This component now. What is this component? I1, I2 into cos phi. So can you conclude something special from this? Theta average is proportional to the product I1 RMS into I2 RMS, then into cos of angle between I1 and I2. Agree everyone?
Yes, sir.
All of you getting this point?
Yes, sir.
Yes, sir.
So when the two currents are having a phase shift, the total average deflection of the electrodynamometer instrument is going to be proportional to the RMS value of product of the currents, RMS value of the two currents. Not only that, also proportional to the cos of the angle between the two. It is difference. That's all. Whatever the difference exists between I1 and I2, that phase angle. What is the difference between I1 and I2? What is the difference between I1 and I2? What is the I1 phase angle? 0 degree. So I1 is here. Understood? Where is I2? Lagging. Understood? Getting everyone?
Yes.
Lagging by an angle 5. With respect to I1, if we take this angle as 0, I1 angle 0, this is I2 angle minus 5. So it is lagging. I2 is lagging. So then what is the angle between them? Phase angle difference between them? 5. Okay. Otherwise, shortly I can say this is your fixed coil current and this is your moving coil current. I can say instead of this also, instead of I1 and I2, a better terminology here is simply say what? Angle between the fixed coil current and what? Moving coil current. Understood? All of you getting?
Yes, sir.
So
Yes, sir.
average is proportional to the RMS current, proportional to the product of RMS currents in coil 1 and coil 2, that is moving coil current and fixed coil current. Not only that, also proportional to the cos of angle between the fixed coil and moving coil currents. If there is a phase difference, if no phase difference between them, if no phase difference between fixed coil current and moving coil current, cos
Yes, sir.
of this will become 0. Then it is function of only I1 RMS and I2 RMS. Understood?
Sir.
All of you getting?
Yes, sir.
Yes, sir.
Okay, now let me use the theta average once again. The theta average is equal to, what is that? 1 by k into dm by d theta. Okay, then we get I1, its RMS value, it is I2 RMS value. Okay, then cos of, okay, cos of what? Angle between I moving coil difference, I fixed coil. Nothing wrong even if you make it otherwise also. The result is same. Now I1 is going to get the load current RMS. I1 is going to sense a load current. And I2 is going to sense, this is your fixed coil and this is your moving coil. I'm going to convert load RMS into the current by a series resistance. Getting everyone? All of you getting? All of you getting?
Yes, sir.
I2 RMS is VL RMS because I'm going to make the moving coil to sense voltage. I'm going to make the fixed coil to sense a current. Understood? So let the fixed coil sense a current to be measured. Okay, current of the load IL. Let the moving coil senses voltage of the load whose power has to be measured. And then tell me what is your phase angle difference between moving coil current and fixed coil current?
V of t and
It is in fact going to become cos of what?
R factor.
I load, angle of I load, difference, angle of V load. It is going to become the power factor of your load. Getting everyone?
power voltage.
Yes,
Getting
sir.
everyone?
Yes, sir.
Then how are you going to read? This is proportional to the current. This is proportional to the voltage. And this is your power factor. Then VI cos phi, that's your average power delivered to the load. Getting everyone?
Yes,
It's
sir.
VL, IL, cos of angle between VL and what? IL. Getting everyone? Yes or no? Yes or no?
Yes, sir.
That's the
Yes,
average
sir.
power delivered to any load. Therefore, we can configure, this is how we can configure our electrodynamometer as a average power sensing instrument. That's a wattmeter. Okay, so that is average power. So we can happily configure this as a wattmeter. The moment I say watt, it's average power or real power or active power. Understood? Understood?
Yes, sir.
Wattmeter reads, you can say the real power, active power, or average power. All are same. Correct? Getting everyone?
Sir.
So now you come back. So what I'm doing now, I'm going to make my moving coil current in phase with the voltage means whatever my angle of V, that's my angle of my IMC. Angle of my IMC will be equal to angle of angle of voltage. Understood? Understood? All of you getting?
Yes, sir.
If angle of moving coil current is in phase with the voltage, if moving coil current is in phase with the voltage, whatever the angle the voltage has, the same angle the current in the moving coil will have. If that is the case, then the reading is proportional to what? The reading is proportional to what?
V.
This is what is this then? This is going to become, this is angle of V, and angle of V, exactly the angle of the moving coil current. Only when these two are in phase it will happen. Then this is going to become power factor. I2 RMS is going to sense VL RMS divided by what? R series. Therefore, this is voltage RMS proportional. This is IL RMS, current RMS proportional. Therefore, the reading will be proportional to the average power. Understood?
Yes, sir.
If moving coil current is not in phase with the voltage applied to it, then it will create power factor error that will result in average power reading error. Understood?
Yes, sir.
Therefore, it is must when you configure electrodynamometer as a wattmeter, the moving coil must be highly resistive. At any cost, it has to be in phase with the applied voltage. That's an important point. Otherwise, you can't configure EMMC as a wattmeter. Understood, everyone?
Yes, sir.
All of you getting?
Yes, sir.
Getting, Rahul? Yes or no?
Yes, sir. Since the resistance is high, the moving coil will sense the load voltage, right?
Yes, moving coil current, moving coil circuit first should be purely resistive. But there is a coil, right?
Yes,
Yes or no? There is an inductance. So therefore, let
yes,
that angle is
yes,
closer
sir.
to 0. It is not creating any phase shift in the circuit. Moving coil circuit is purely resistive. I can't say highly resistive. Purely resistive is ideal requirement. Then only they are in phase. Moving coil circuit is highly resistive, is made highly resistive. Getting everyone?
Okay, sir.
It is highly resistive means how much magnitude of current will go through that. Since it is highly resistive, is huge resistance we are going to consider. R series is going to be very, very greater than what? Is at MC, in fact,
RM.
net impedance of the moving coil.
Yes, sir.
So then what current will go? Only a small current will go
Very
through the
small current.
moving coil. But how to compensate for the small current? With the small current, I need to make a huge MMF. Then who is making the MMF? Magnetomotive force. N2 into what? I2
The
is the
current.
moving coil MMF. MMF of moving coil is N2 into I2. Therefore, use more number of turns in the moving coil. All of you getting?
Yes, sir.
Yes.
Yes,
By
sir.
default, the potential coil of a wattmeter always will have higher number of turns comparing to the current coils. Getting the point?
Yes, sir.
Yes.
Okay. Yes. N2 will be always greater than N1. Okay. Whereas N1 I1? N1 I1 because already it is N1 I1 is what? I1 is the load current. Load current is going through the what? Current coil. Therefore, already huge current is going. Then let this produce less MMF. Okay. That means desired MMF by having less number of turns. Getting everyone? N1 with less turns. That's a rule of thumb for the electrodynamometer wattmeter. Fixed coil will have, current coils will have less number of turns. Potential coil will have more number of turns to set the desired uh, electromagnetic flux or stator flux and desired rotor flux, I can say. Getting everyone? Understood?
Sir,
Yes.
can you repeat the point again, sir? Less number of turns in one.
Because current through the load is actually you are not restricting the current in the current coil, Rahul. What is the current through the current coil? Fixed
Okay,
coil.
sir.
What it has to
Yes,
sense?
sir. The load current.
Load current. Then load current,
Load
entire
current.
load current is going as it is in the order of amps. But whereas if you see the moving coil current, it is going
Yes,
to be
sir.
in the order of milliamps. All of you getting?
Okay, sir.
Understood now? Ultimately, you have to create desired electromagnet flux and what? Desired moving
Okay.
coil flux. Correct? Who is responsible for
To
this?
compensate for that, we are.
Yes, this is N1, I1. Getting Rahul?
Yes, sir. Got
I2
it.
is very
Yes,
small,
sir.
therefore let higher number of turns. I1 is very large, let N1 is lesser number of turns, few turns. Getting? Yes or
Yes,
no?
sir. Getting, sir.
So with the few turns itself, we can create desired MMF. Okay, this is MMF. This is also what? MMF. Are you getting, Nirmala, getting the point?
Yes, sir.
Okay, so that's a point, especially when you configure electrodynamometer as a wattmeter. Understood? Understood? All of you getting?
Yes.
So that's a way to configure electrodynamometer as a wattmeter. Okay. So let me give you the power measurement using wattmeter. Yes, instrument is ready. Let us start measuring. Okay. Power measurement, single phase power measurement using electrodynamometer type wattmeter. Any doubts, Rahul? Still?
No, sir.
Okay. This is my load. Let me have an inductive load. This is my single phase AC source, single phase, 230 volt, 50 hertz. Let me take that way. If you want to have a round number, let me take it 200 volts. Single phase, 200 volts, 50 hertz supply is given. You can take this as phase and neutral. This is your load current, IL, and this is your load voltage, VL. Getting everyone? And this is your load, ZL. ZL is given, for example, 10 at an angle 45 degree. 10 at an angle 45 degree ohms. That's a impedance. Tell me what's the current in the circuit. I of t. Tell me what's the current I of t or I.
20 angle 45.
I load. I load is equal to, yes. Okay, IL will be its a phasor quantity. VL is also phasor quantity. We'll have a magnitude. Modulus of IL is RMS load current. Modulus of VL is RMS load voltage. Take that way. Okay. So IL.
20
20.
Okay. Supply
angle
voltage is
45.
VS. So if nothing mentioned, VS should be taken as 200 at an angle 0 degree. Okay. That's how it has to be
0
taken. If
degree.
angle is not mentioned, by default reference is 0. So 200 at an angle 0. So what's the load current then? Vs divided by the load impedance. That's all in the circuit, right? Directly you're connecting source to the load, inductive load. Maybe it is connected to a single phase fan. That is given as 10 angle 45 degree ohm. We can treat that way. Yes. So 200 at an angle 0 degree volts divided by 10 at an angle 45 degree ohms. Yes. Tell me what's the load current? 20 at an angle minus 45 degree amps. Getting everyone? All of you getting?
Sir.
So current lags,
Sir.
voltage.
It's
This is your voltage. What is that? Supply voltage. In fact, supply voltage also equal to your load voltage in this case. Agree everyone? Because load is directly connected with what? Supply. So what is VL? VL is equal to 200 at an angle 0. Getting everyone? Yes or no? Yes or no?
Yes, sir.
yes, sir.
Then where is the current? This is 90 degree, minus 90 degree. Then this is minus 45, correct? So then with the less magnitude represent your
Yes,
load
sir.
current. What is the load current then? Load current is 20 at an angle minus 45 degree amps. Now what's the phase difference between? So clockwise rotation, so lagging. So what is the angle? 45 degree between them. So angle difference between voltage and load voltage and load current is equal to 45 degree. This is a setup, okay, where I want to measure my power. Now tell me what's average power delivered to the load. Tell me that's what we are going to measure. Tell me what's average power delivered to the load. It is modulus of VL, modulus of IL into cos of what? Angle VL minus angle IL. Okay, cos of phase angle between load voltage and load current. That's a fundamental. In order to say it is phi, go for the phase angle difference between the two. That's a average power or real power or active power. Yes. What is the magnitude? 200 volts. What is the magnitude of current? 20 amps RMS current. And what is cos
20
angle of
amps.
the phase difference between the two? Phase difference between the two, 45 degree. Understood?
45.
You can take minus also, no
Yes,
problem.
sir.
Cos of minus 45 also, cos 45 only. Okay. Now tell me what's average power delivered to the load. This is what we want to measure.
4000 by root
Cos
2.
45 is 1 by root 2.
Yes, sir.
Yes, sir.
Okay, then 4000 by root 2. Okay.
Yes, sir.
Getting all of you in kilowatts. 4 by root 2 kilowatts, I can say. Getting?
Yes, sir.
Yes, sir.
Getting, Nirmala?
Yes, sir.
Okay, yes. This is your
2
setup.
root 2 kilowatts.
Single phase. This is your load. Directly you connected load with the power supply. Now you want to make the power measurement. Getting Rahul?
Yes, sir.
Now let me introduce the instrument. So first I'm giving you the setup where you want to measure the power. Okay, you got the clarity about what is happening in this. Now let me introduce the instrument. This is a test setup. Okay, this is the ambience where you want to use your instrument. We'll see how the instrument is going to read this average power, which is 4 by root 2 kilowatts. What is the answer actually? 4 by root 2 kilowatts means in watts, please. That's the average
0.8
power
kilowatts.
average or power of the
5.65
load.
kilowatts.
How much? Rahul, how much?
5.65.
5.65.
2828.47 watt.
Any mistake I committed?
2.828 kilowatts, sir.
Rahul, 4, not 4 into root 2, 4 by root 2.
Okay, sir.
Yes, Nirmala.
828 kilowatts, sir.
2.82. Okay.
2.82.
2828 watts.
Yes,
Correct?
sir. Yes, sir.
2828
Yes, sir.
kilowatts. Sorry, watts it is. Okay. Understood, everyone?
Yes, sir.
That's average power. So now let me bring the instrument into the picture. This is my instrument. This is how we are going to represent our instrument. This is the instrument is going to be represented by only the 2 terminals for your current coil. Only 2 terminals. That's a short representation of electrodynamometer type instrument. 2 terminals for the current coil. Then 2 terminals for the potential coil. So we have to mention with higher number of turns. That's a potential coil. Getting everyone? All of you getting? But potential coil should be always connected with what? A huge series resistance. That will be by default should be shown. Okay, that's the setup. That's how we need. This resistance may be internal or in series with the potential coil. Sometimes they will show this internal. It has to be internal. Okay, otherwise when you are converting the instrument into wattmeter, you need to connect this externally. All of you getting? All of you getting?
Sir.
Okay, so make this
Yes, sir.
external.
Yes, sir.
Because when you extend the range of the potential coil, a different series resistance will come into picture. They will say 200 volt position in the wattmeter or 400 volt position, something like that. 1 minute. 200 volt, 400 volt, okay, like that they will mention 800 volt, something like that. Okay, they will say accordingly a suitable multiple resistance. 200 volt they will connect one resistance. 400 volt they will connect something else, because you need to limit the current through the potential coil. Getting everyone? Getting everyone?
Sir.
Otherwise the best thing is, okay, assuming you are going for only single range, then let that resistance also in series with the potential coil. That's all. So 2 terminal for the current coil and 2 terminal for the potential coil they will mention. Okay, that's a wattmeter setup. Okay, getting everyone? Then they will mention this in the instrument. There is a mentioning. This will be mentioned as a main, and this will be L, M, L, and this will be mentioned as V, and this will be mentioned as C. Okay, this is the mentioning wattmeter. This is what you will see. Okay, it's only the representation. This is only a diagram they will draw, and they will show the actual terminals only. To understand what terminals they are, they will have the, you will see the diagram in the panel of the instrument. Okay, in the panel of the instrument, you will see this M, L, C, and V. Okay, that is your watt meter. Getting everyone? Then what you have is, you have your load, whose power has to be measured accurately by this instrument. Now you can understand what L represents. Where is your load? Right side or left side?
Right, sir.
Yes,
Right side.
that is the load. Not line, it is a load. It is a load. L represents load. M represents your power supply mains. So it is connected to mains. M is mains. L is load. Understood? Okay? Yes or no?
Yes.
Yes, sir.
200 volt, single phase, 58 supply. This is your phase and this is your neutral. So connected to mains. And this is load. And usually you need to go for a connection. So either you can go for M to V connection. Okay. Otherwise, sorry, L to C connection. It's up to you. You can make this connection. MC, LV, you can wire them. So what is recommended is LV is recommended. Otherwise, you can also make the connection sometimes. LC also they will connect. Okay. They will connect V to the ground. That's a mistake. V has to sense. It's a potential coil, right? So V should be connected to whom? We should sense what? Load voltage, correct? Therefore, where is the load voltage? This is your load voltage. This is your load voltage. Who is the reference?
Yes, sir.
This is 0. Then where is the load voltage? Here is a load voltage. Connect V to this point. V and L should be connected. Understood? That's a physical connection we need to make. Okay, you have to make the physical connection. Okay, so not only 2 terminals, you have 4 terminals to connect. L connected to the load, not line. Okay, it is not the supply, it is a load. M represents your power supply mains. V represents voltage sensing point, sense the voltage of the load, because the potential coil has to sense only what? Voltage of the load, right? Yes or no? Potential coil is going to measure, sense the voltage. Current coil is going to sense the current. Load current should go through the current coil, and load voltage should be across your potential coil. That's what it means. And C is a common of your circuit. Understood, everyone? Got it? All of you getting this?
Yes. Yes, sir.
Okay. Now, this is your load. What is the load? 10 at an angle 45 degree. Understood?
45 degree.
Now, how to get the reading of the instrument? Watt meter reading. We should know what this instrument reads finally. Okay, so tell me what is the voltage the potential coil is sensing. Reading should be taken this way. What's the reading? Reading is equal to the potential coil voltage RMS, the current coil current RMS, then cos of phase angle between potential coil voltage and the current coil current. That's all the instrument will do. All of you getting? All of you getting?
Yes, sir.
It's calibrated. After the calibration, this is what the instrument is doing. The instrument is least bother about what is the load current, what is the load voltage. It will see what is the potential coil voltage, what is the current coil current, and cos of phase angle between them only it will take for the reading. Okay, it won't see what is happening in the load. All of you getting the point?
Yes, sir.
Now tell me what is the potential coil voltage in the given circuit. What is the potential coil voltage? Potential coil voltage. Potential coil is connected in parallel with the load. Correct? Yes or no?
Yes, sir.
Therefore, sensing the load voltage. Understood?
Yes, sir.
Yes, sir.
Then current coil current. Current coil current. This is your load current. What is the current coil current then? Current coil current is, there are 2 currents. One is current through the potential coil. Another one is current through the load. Therefore, it is going to be load current plus potential coil current. All of you getting?
Yes, sir.
Agree?
Yes, sir.
Yes, Nirmala, following, right?
Yes, sir.
But already we made potential coil highly resistive. Then what will be the current potential coil current comparing to IL? Comparing to the load current, the pressure coil current or potential coil, pressure coil means, so that is pressure means the potential. Okay, so either you can call it as a pressure coil or potential coil. Okay, because pressure difference is related to potential difference. Understood? Pressure difference, a mechanical flow. Okay, so here it's electrical flow. Okay, so nothing wrong in calling this as a pressure coil. Sometimes the problem designers will use potential pressure coil instead of potential coil. Okay, so that's a pressure coil current or potential coil current, that is highly resistive circuit, therefore it is negligible. This is very less comparing to load current, therefore discard this. Therefore current coil current is approximately equal to current
Load
coil
current.
current is approximately equal to load current.
Load.
So what is the point? The potential coil senses RMS of your load voltage. Current coil senses RMS of your current. In fact, potential coil senses the entire load voltage, including the phase information. Current coil, okay, since there is no phase created, okay, there is no phase, there is no current we are considering. Therefore, the current coil current phase information will be in phase with the load current. Therefore, the phase angle of your load current will be the phase angle of current coil current. Phase angle of load voltage will be equal. This is the one making the pressure coil current. VPC only making the pressure coil current. Why I talk about pressure coil current now here means because the instrument is going to give the deflection only based on the two currents. What current? Pressure coil current and current coil current. Understood? Understood? All of you getting? Yes or no?
Yes, sir.
Yes, Rahul,
Yes,
following,
sir.
right?
Pressure coil voltage and current coil. Yes, sir.
Pressure coil phase angle should be same as the load phase
Voltage.
angle. Pressure coil current phase angle, anyway pressure coil is
Okay.
in phase with the load voltage automatically, correct?
Yes, sir. Yes.
The pressure coil current
Yes.
is
Yes,
automatically in
sir.
phase with the load voltage. So therefore, the reading of the instrument automatically proportion, because what is the angle of your voltage of phase, pressure coil? It is angle of your load voltage. What is angle of your ICC? Angle of your load current. Then what is this actually? Power factor angle of your load automatically. Getting everyone? Yes or no?
Yes, sir.
Yes, sir.
Then what is modulus of VPC? Modulus of VP is equal to modulus of VL. Modulus of IC is equal to what? Modulus of IL. Getting? Into cos of the power factor angle between load voltage and, cos of phase angle between the load voltage and load current. That's a power factor angle or power factor of your load, we can say. Getting all of you?
Yes, sir.
Tell me what's the reading now? What is the reading obtained? Same as we evaluated earlier. What is the average power delivered to the load? 2828 watts. That will be the reading. All of you getting? Yes or no?
Yes, sir.
Therefore, the meter will read 2828 watts only. Yes, Dhanvarsha?
Sir, in the derivation, I could clearly understand. I mean, if the phase shift means between IPC, how it will be affecting, sir. But here, directly we are measuring VPC only, no, sir. So why IPC should be in phase now? The instrument, if we see.
Because what is your electrodynamometer instrument? Sensing the voltage or current through the moving coil?
Actually, it will sense current, sir. But now we are
We
sensing voltage.
converted that into, see, actually the pressure coil is like a voltmeter. Current coil is like a ammeter. Understood?
Yes, sir.
Current coil is sensing the load current, so it is like an ammeter. So
Okay,
your
sir.
electrodynamometer wattmeter, now we are configuring one coil to act as a ammeter, another coil to act as a voltmeter. Understood?
Yes, sir.
That's the reason.
Okay,
Okay, but
sir.
anyway, both the coils are making the MMF only function of the current through them. So therefore, it is making sense to talk about the current through the current coil and current through the potential coil. Understood? Dhanvarsha.
Okay, sir. Okay, sir.
Yes. Anyone else having doubts? Yes, Monopriya following.
Yes, sir. Following, sir.
So, but the real
Sir?
problem will come. Yes.
Sir, phase IPC and VPC should be in phase, sir.
It should be.
Similarly, ICC and IL should be in phase.
That's by default. It will be.
Okay, sir.
Okay, it should be. Understood?
Okay, sir.
All
It
of
is
you
not
getting?
necessary that VL and IL should be in phase, no, sir?
That depends on the load.
Okay, sir.
Okay.
Okay, sir.
Load is not in our control. Load someone
Okay.
decides. There is a setup. I
Yes.
don't know what is my load, but I want to measure the power. As of now,
Okay.
I have given you the test circuit only to understand what is your test setup, what is the true power you should know. Because before measuring power, you should know what power you are measuring. Understood?
Okay, sir.
That is the true power. What is the true power? Earlier we evaluated 2828 is the true power. Now the instrument has to
Okay.
give the same power reading. Then only we will understand and appreciate it is maintaining 100% accuracy.
Okay,
Getting
sir.
Monopriya.
Okay, sir.
Okay, all of you getting this point?
Sir.
Yes, sir.
Can you pinpoint a problem with this setup? Can you pinpoint a problem with this setup?
R is very high. Will there be power loss, sir?
If the pressure coil current is significant, then the current coil will sense more current than your load current. Yes or no? All of you getting?
Sir, repeat, sir.
If the pressure coil current is significant, assuming the load current is 10
Yes,
amps
sir.
and the pressure coil current is 0.2 amps, then what is the current coil current then? Instead of sensing 10 amps current, it will sense 10.2 amps current. Yes or no?
Yes, sir.
Then definitely it is going to produce some extra flex. Then it is going to deflect little extra. Then it is going to read extra. Yes or no?
Yes,
Getting Nirmala?
yes, sir.
Yes, Dhanvarsha following right?
Yes, sir. Following, sir.
So then what is the problem? Which coil is sensing correctly? We are expecting the current coils to sense the load current. We are expecting the pressure coil to sense the load voltage. Who is perfect? Who is imperfect in this circuit connection? In the given circuit connection, who is perfect? Who is imperfect?
PC is perfect, sir.
It's
Pressure
a
coil.
Pressure coil is perfect because it is sensing the load voltage.
low voltage.
All of you getting?
Yes, sir.
Yes, sir.
Yes, sir.
But whereas your current coil is imperfect because it is sensing the load current plus pressure coil current. Therefore, there is a chance of committing error. Understood? Yes,
Yes,
or
sir.
no?
Yes, sir.
In fact, your load voltage won't be equal to 200. Tell me why.
There will be some drop in CC current coil.
Yes, drop across current coil. Assuming resistance, okay, considering a small resistance of the current coil, a 0.1 ohm also. You take 0.1 ohm current coil resistance. What is the current going through the load? 10 amps. 10 amps into 0.1. 10 amps into 0.1. 1 volt you lost. Instead of 200, you will be getting only 199. Understood?
Yes, sir.
So always we can find fault with the wattmeter connection. Whatever you do, you can find fault with the wattmeter connection. Therefore, the wattmeter reading always little lesser than the true value only. Getting everyone?
Yes, sir.
Okay, so once values of potential coil resistance and current coil resistances are given, then we can think of, okay, what is the real fault? Okay, now let me try. Suppose instead of this LV connection, now let me make the connection something little different. Okay, let me make the connection this way. This is your C. Let MC is made and this is made. V is nothing wrong. Still potential coil is going to sense a voltage. Now tell me what's a potential coil voltage? The potential coil is going to sense supply voltage. That will be exactly 200 at an angle 0.
Yes,
Yes
sir.
or no?
Yes, sir.
But who is correct? Who is wrong? What about current through the load? IL. Correct? This point is 200 at an angle 0. Understood now? So now what is the current going through the current coil?
Yes, sir.
What is the current going through the current coil?
Same as
Exactly the
IL.
load current. So in this case, current
Yes.
coil is perfect. Potential coil is imperfect. Tell me why imperfect? Because load voltage will be little less than supply voltage. Therefore, your potential coil senses little higher voltage than what actually the load voltage is. Understood?
Yes, sir.
So in both the
Because
scenarios,
of drop in 60, sir.
yes, okay, there is a drop in current coil as well. Understood? So by the time current
Yes,
coil
sir.
senses the current through the load, but potential coil senses supply voltage instead of load voltage. Understood? Yes or no?
Yes, sir.
Yes.
Potential coil senses supply voltage instead of what? Load voltage. Earlier, current coil drop is immaterial. Earlier, current coil drop is what? Immaterial. That's not an issue. So here, it is sensing perfectly the load voltage, no problem. But what is the only issue? Current coil current is little more because of the pressure coil current. Understood? All of you getting?
Yes, sir.
Yes.
So, both connections will give error. Either this connection that's your instrument. Either this connection, that's your load. That's a connection 1 you can take. And this is connection 2. Resistance can be connected anywhere, not an issue, because they are in series. That's your usually the thing is current coil show less turns, pressure coil show more turns. Getting all of you? That's all. Okay, this is connection 2. Understood? Both are error connections only. Agree? This senses current coil current is exactly sensing the load current, but this is the load voltage. Assuming a small drop across this current coil, then your pressure coil voltages VCC phasor sum with what? VL. This is a little extra reading. And here, this is your load voltage. And here the pressure coil senses exactly what? Load voltage. Because instrument has to sense load voltage and current coil has to sense a load current. Okay, so but unfortunately the current coil current is, this is pressure coil current and this is your load current and this is your current coil current becomes little more, therefore it is pressure coil current plus load current. Here in connection 2 current coil commits a mistake, whereas in connection 1 pressure coil commits a mistake, therefore the reading is always wrong in connection 1 as well as connection 2. Getting everyone? Yes or no?
Yes.
What's the remedy? We'll see the remedy soon. Okay, both results in error. Error in power measurement.
Sir,
Yes, Tanvisha.
but in machines lab, usually they will connect M and C only, no, sir. Is there any reason for that, sir?
This is your M. This is your C.
Ah, yes, sir.
And this is your V. Okay.
Yes, sir.
And this is your L. It's up to you, not an issue. Because
Okay,
V,
sir.
M and C will connect, but V you will choose, resistors will be there, right? Because
Yes,
this
sir.
is your resistance, Tanvisha. Okay, this actually the practical setup is this. Okay, in the V you have a switch that will have multiple series resistors. It's like a voltmeter extension. This can be connected to this your V. It can be connected to 200, can be connected to 500, can be connected to 1000, something like that. Getting?
Okay, sir.
Getting Tanvisha?
Yes, sir.
Okay, the voltage has to be chosen. Okay, either 100 volt range, 200 volt range, or 400 volt range, something like that. It's like a voltmeter extension. Understood? With
Yes, sir. Okay, sir.
series multipliers. That's why. Okay, that's connection. Understood?
Yes, sir. Okay, sir.
Nothing wrong will happen. Okay, even if you make L and V. Understood?
Okay, sir.
Okay, yes. That's all. Both are resulting in error. Which one will give you less error? Without analyzing, we can't conclude. Getting the point? You need to separately analyze connection 1, separately analyze connection 2, then see which one gives reading accurately. That's suggested. Understood?
Yes, sir.
All of you getting this point?
Yes, sir.
We'll go for the remedy soon. Okay, that's how a power measurement in single phase can be made using electrodynamometer type instruments. Okay, we'll have a few basic example, then let us get into a remedy for this, and then we'll get into three-phase power measurement. So problem will give us more clarity. Yes. First problem to begin with. That's from GATE 2015, 2 marks electrical. So always yes, you have to draw less turns for fixed coil, more turns for moving coil or pressure coil. Yes. We can answer the problem. So two coils of a wattmeter having resistance 0.01 ohm and 1000 ohm. Sorry, the coils of wattmeter. So you have to decide what coil they are. He didn't say current coil or potential coil. You have to decide it. Yes. Tell me which one should I take? Lesser
1000 ohm
value
is for
resistance
PC, sir.
and more value
1000
to.
ohms of pressure.
So this is
It is 0.01, sir.
this is
1000, sir.
understood now?
Yes, sir.
Yes.
Sir.
That's by default because pressure coil should be highly resistive. Okay. Understood? Because it has to limit the current also. Fine then. This is your current coil resistance. This is your pressure coil resistance. Their inductances may be neglected. Okay, we are happy about it. Then the wattmeter is connected as shown to measure the power consumed by the load, which draws 25 amps current. Okay, 25 amps current at a power factor of what? 0.8. Power factor of the load is given. Okay, power factor of the load is given as 0.8. What's the voltage across the load terminals? 30. Understood? Load voltage. What is given as mod VL is given. What is given as mod IL is given. All of you getting? Mod IL is 25. Mod VL is 30. No phase information given in the voltage and current. But power factor is given. With that you can find out the load power factor. Yes. What is the load? What is the load impedance? Load impedance, please. Load impedance, please. Modulus of VL, angle of VL divided by modulus of IL and angle of IL. That's how we go with. Understood? Yes or no?
Yes, sir.
So we know the magnitude of the impedance alone. Okay, so from this, what is given? Phase information not given. So we can't find the phase of the load. Okay, we can find the impedance, magnitude of the load. What is the load magnitude? VL by IL. What is that? 30 by 25. Getting everyone? Yes.
Yes,
1
sir.
point.
2.
1.2 ohms is the load. And we know the average power. Okay, so power factor is given. What is the power factor? Power factor is cos of what? Phase angle between your load voltage and what? Load current only. Yes or no? Yes or no?
Yes, sir.
Yes, it is also given. But we don't know whether the data is necessary or not. Just I'm giving you explanation what is given in our setup. Understanding everyone? Yes or no? All of you getting?
Yes, sir.
Now tell me, what is the power factor? 0.8. So then you can take this as a phase angle difference between voltage and current of the load. Then I will take this as 30 at an angle 0. Then add this extra current, phase angle to the current alone, taking voltage as a reference. All of you getting? Take voltage across the load as a reference, then take the angle, okay, difference to the current, either negative or positive, depending on your load assumption, inductive load or capacitive load. All of you getting the point? Power factor is equal to cos phi. So tell me what is phi? That's an angle between the voltage of the load voltage and load current. Yes, what is phi? Cos inverse of 0.8. Tell me what is that?
36.86, sir.
Yes.
36.86.
36.86 degrees. So let me assume voltage is my reference, that is VL, and current is lagging behind your voltage by an angle 36.86. Then, okay, you can go for the average power. Okay, fine. Then this is your setup. Okay, this is for extra understanding. Now the question is the percentage error on the wattmeter reading. How you will calculate the percentage error? First, you should know the true value. Then you should know the measured value. How to get the true value? Only by calculating the true power of the load. Yes or no?
Yes, sir.
Tell me what's average power delivered to the load. That's a true power. That's what we are measuring. Yes. Tell me what's a true power. Power average. The average power delivered to the load. That's a true value to be measured. What is that?
PA
Mod VL. Mod IL.
600.
VLIL cos phi. The power factor. Directly, you need not to use 36.86, directly, 0.8. So 30 into 25 into 0.8. That's a true power we
600
are
watts.
measuring. How much?
600 watts.
600 watts we are measuring. Now tell me what will be the instrument reading. And inductance of the current coil and pressure coil are neglected. We need to treat only purely resistive current coil and purely resistive potential coil, like that we need to treat. Now tell me, what is the current here? What is the current here exactly? Assuming this angle is 0. Okay, this angle is 0. Tell me what is the voltage across the potential coil? Voltage across the potential coil is same as your load voltage, that can be treated as 30 at an angle 0. All of you getting?
Yes, sir.
Now tell me what is the current, okay, in the load. It is 25 at an angle minus 36.86, assuming inductive load. That's an assumption. Inductive load. Okay, all of you getting? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Now tell me what's the pressure coil current is. What is the pressure coil current? 30 angle 0 by 1000. That's a pressure coil current. 30 angle 0 by 1000 means 0.03 at an angle 0 only amps.
Yes,
Understood?
Yes, sir.
yes, sir.
30 by 1000. Yes, 30 angle 0 by 1000. So 0.03 angle 0. Tell me what is the current. Don't commit a mistake, okay, without considering the phase angle. If you don't consider the phase angle, you will get the current coil current as 25.03. Getting everyone?
Yes, sir.
Yes,
And can
sir.
you tell me accurately? Considering the phase angle, tell me what is the current coil current. Current coil current is 0.03. Okay, that is a real. Plus, you need to convert this into rectangle form. Convert this into rectangle, then get the real plus imaginary, get the magnitude of the current going through the current coil. That's accurate analysis. Only if they say approximate, you can approximate.
20.0025.
ICC equal to IPC plus the load current. IPC is
Load current.
0.03 at an angle 0 degree plus I load is 25 at an angle minus 36.86 degrees. Yes, VPC is already known. That is a load voltage, that is 30 at an angle 0. That is perfectly all right. No problem with the VPC. Yes, ICC, please.
25.0240.
This one, what is this? This component alone, then measure.
Total only calculated.
Okay, total is
25.024. Angle minus 36.86.
okay. Okay, you got it into polar form again. Okay.
Yes, sir.
Okay. At an angle?
Minus 36.86.
Again, almost same angle. Huh?
Same angle only, sir.
Okay. All of you getting this? Yes. Nirmala, confirm. Rahul, confirm.
Yes, sir. Same answer, sir.
Okay, then. Tell me reading of the instrument.
Yes, sir. Same.
What is the reading? Modulus of VPC, modulus of ICC, cos of angle of VPC, difference angle ICC. That's all. That is your reading of the instrument. What is VPC? 30 volt. ICC 25.024. Then cos of this angle, no change in phase angle you said. So it is going to be cos of minus 36.86 or 36.886. So it is going to be 0.8 approximately. Then 30 into 25.024 into 0.8. That's an instrument reading. Yes, we are concerned about angle of potential coil voltage, angle of current coil current. That's very important. If it is inductive, if the pressure coil is inductive, okay, or RL load, that will have a phase lag. That angle won't be equal to the power factor angle. Okay, the instrument power factor angle will be different and load power factor angle will be different. Then it will be huge error in the measurement of power. Getting everyone? Yes or no?
Yes, sir.
That's why the pressure coil current should be
Yes, sir.
in phase with the pressure coil voltage, because pressure coil is sensing the load voltage, so it should be in phase with the load voltage. His answer is
600.576 watt.
can you tell me 25.03 into 30 into 0.8? Assuming I am taking directly this 0.03, adding with 25 without phase information. I don't consider the phase information. I'm adding this 0.03 with 25. 25.03 I will get instead of what? 25.024. All of you getting? Tell me what significant difference it makes. That's error. Manipulation error. You should go with the phase information. That's very important. So tell me what is 30 into 25.03 into 0.8.
600.72.
600.72.
600.72. And remember, it's a numerical answer problem. Okay, you're going to give the error. 0.72 will make a higher error. 0.576 will make a lesser error because we are going to play in terms of percentage. Getting everyone?
Yes, sir.
So this is wrong. You should not do this. Okay, right? You should not simply add the pressure coil current magnitude with the load current, because load current is in phase. Pressure coil current is also having phase. Play with the phasor addition to get the current coil current. This is the right step. Happy everyone?
Sir,
Understood? Yes, Tanvarsha.
instead of considering as inductive load, what if we do as capacitive load, sir?
Then angle will become plus 36.86.
Yes, sir. So that will make any change, sir.
No change. Then here
Okay.
also you will get plus 36.86 only.
Okay, sir.
You
Because
try
cos.
Tanvarsha.
Okay, sir.
Instead of 25 angle minus 36.86, you take 25 angle plus 36.86.
Okay, sir.
Because current is leading capacitive load, correct?
Yes, sir.
So what is your load? I'm not actually, the problem is not with respect to the load. I don't want to talk about the load angle. Load angle is your impedance, power factor angle. What is the load actually? If you want to talk about the load, if you want to have a better understanding, what is your load? You got the impedance. What is the impedance? 1.2. Then what is your ZL? Can you tell me anyone? 1.2 at an angle 36.86. That's your load. All of you getting? All of you getting?
Yes, sir. Okay, sir. So inductor we can
Now
confirm.
you give 30 divided by 1.2. 30 divided by 1.2. 30 divided by load. What do you get then? 30 by 1.2 will become 25.
Yes, sir.
The denominator 36.86 will become minus 36.86. That's how I took it here as a current. Okay, probably some of you had doubts there. I took my load, okay, with the magnitude and phase angle. That's what it means. Because I referred this perfect angle. This angle can be taken as plus means RL, minus means RC. Understood?
Yes, okay, sir.
So result is same then, Varsha.
Okay, sir.
Okay, you try that also. Okay, later.
Yes, sir.
Sir?
Getting Rahul? Yes, Monopriya.
Yes, sir. Sir, the error is due to what, sir?
What is your true value of power?
600 watt.
Then what is the reading now?
600.576.
Why? Current
Because
coil
of the
current is
current
what?
changing, sir.
Okay, why? Current coil current is not only your load current, it is also sensing the pressure coil current.
Okay,
These are
sir.
the points we discussed earlier. Connection 1, connection
Okay,
2,
sir.
both are okay, erroneous. Will give the result with error only. Understood?
Okay, sir.
That's what we are talking
Understood.
about now through this example. Getting everyone? Yes.
Okay,
Yes,
sir.
sir.
Measured value 600.576 watts. True value,
600.
okay, actual power of the load. Therefore, the percentage error is equal to measured
0.096.
value minus true value divided by true value into 100%. Okay, let me check. Okay, error means you have to go for only error. Error means measured value minus true value. That's your error. So error may be defined in terms of watts. Then it is reading more or less.
Reading more.
Reading more. Therefore, error is positive. Okay, error positive reads says the instrument reads little more. So positive error. So 0.576 watts is the extra reading by the instrument because it is not only sensing the current through the load, it is also sensing the current coil. Not only it is expected to sense only load current, but unfortunately sensing the small current going through the pressure coil as well. So producing extra flex, producing extra deflection. That's understanding. Getting everyone?
Yes,
Clear?
sir.
All of you clear about this?
Yes.
Nirmala following this?
Yes, sir.
Yes, answer please. Rahul, answer please.
0.096
0.096%.
percentage. Okay, so refer the original paper, refer the key. Okay, numerical answer type problem, refer the key. Okay, getting
Yes, sir.
everyone? Yes. That's an interesting problem to begin with. Okay. Yes, you can answer this problem. Single phase power measurement. I think this problem is common in 2012 for both electrical and instrumentation gate papers. Yes, the answer is 1 mark.
A option, sir.
Option A. Half of E1 I1 cos phi 1. Okay. Maybe, I'm not sure. Nirmala?
Yes, sir.
The load current is given. Load voltage is also given. Supply voltage is given. Supply voltage is falling across the pressure coil of the wattmeter. Okay. The average power measured by the wattmeter. So find no fault to the instrument. Assume the connection is perfect. Okay. What is the current coil current? What is the current coil current? I of t. That is the load current. But only fault is wattmeter potential coil is not sensing the load voltage. It is sensing V of t. What is given is V of t. It is not the load voltage. Supply voltage is given. But you can't consider the drop across the current coil because no information is given. Assume current coil is an ideal ammeter. Current coil is an ideal ammeter. What is the resistance of ideal ammeter? Resistance of ideal ammeter?
0.
0.
0, sir.
Then no drop across it. Similarly, you can also consider when the instrument is ideal, no current through the pressure coil, no voltage across current coil. So your current coil treated as an ideal ammeter, potential coil treated as a ideal voltmeter. Understood everyone?
Yes,
Getting?
sir.
Yes,
Yes,
sir.
sir.
Okay. Then there is no error if that is the case. And even with the consideration, we got the error as only how much? 0.096. It is not even 0.1%. Okay.
Yes,
Getting
sir.
the point. Even in the last connection, the error is not even not 0.1% also error is not there. 99.9% accuracy is still maintained. Okay, so irrespective of this connection, you still get almost accurate reading. That's a problem, but it will little over deflect, but still we can go for a compensation for that little later. We'll see. Yes,
Sir,
what is
I
the
think
answer now?
option C, sir.
Option C. Okay, by Dhanvarsha. Yes. A by Nirmala. Yes, Rahul, Monopriya.
Option C, sir.
Okay. Getting Nirmala? Fundamental.
Yes, sir.
Option C or A? Instantaneous power P of t is equal to V of t into what? I of t. When you go for the average power, assuming instrument has no fault, average power it is reading, therefore go for the average power. So 0 to t 1 by t instantaneous power into dt. So when you multiply your components of V of t with the current, E1 sin omega t multiplied with the corresponding fundamental alone will make power. That's a first power,
Yes.
first average power. Understood?
Yes, sir.
Rest of them will vanish. Understood? E1 sin omega t multiplied with I3, that is 3 omega, and this is third harmonics, and this is what? Fifth harmonics, correct?
Yes,
So
sir.
then, even if with the even harmonics also, if you multiply one frequency with any other, okay, then the resultant average will be automatically 0. Okay, this point we discussed earlier in circuits as well, I guess.
Yes, sir.
So here, same point, playing with the instrument as well. That's all. Okay. So E1, I1, E1 sin omega t, I1 sin omega t will make the average power. What is the average power? What is this? E1 peak value given. What is the average? E1 by root 2. That's RMS. And this RMS current, I1 by root 2. And cos of phase angle difference between them. What is the phase angle difference between them? Phi 1 is the phase difference between them. Understood?
Yes, sir.
That is one. And similarly, when E3 sin omega 3t, sin 3 omega t multiplied with I3, then this will create an average power. Rest of them will fail to make any average power. Understood?
Yes,
5
sir.
omega component not there. So this is your third frequency component. So P3 average. What is the P3 average? E3 by root 2. Then I3 by root 2 cos of phase angle between them. What is the phase angle between them? Phi 3. So the answer is
C, sir.
okay. Getting everyone? Getting Monopriya? Getting the
Yes, sir.
point?
Getting. Yes, sir.
Okay.
Yes, sir.
Yes. That's how it goes. Okay. So nothing to play with the wattmeter. And what is the only information you should know? He said the average power measured by the wattmeter. By default, wattmeter measures only what?
Average power.
Average power. Okay, right? Is
Average.
that true?
Yes, sir.
Is that true for the reading?
True, sir.
No. The reading of the
No,
wattmeter
it
is
will be slightly
always
higher.
reading of the wattmeter is always modulus of VPC, modulus of ICC, cos of angle between VPC and what? ICC. That's what the instrument knows. Understood? Understood?
Yes, sir.
Yes, stick to this.
Yes, sir.
Okay. Instrument never reads average power of the load. Okay. Only when you make sure the situation across your instrument is identical to the load, you will get the accurate reading. Otherwise, okay, always such an error will be resultant. Getting everyone? Understood? Any connection you make, always there will be a measurement error. Understood? Yes or no?
Yes, sir.
Understood, sir.
Yes, sir.
So why the error is coming? Because your
ICC
instrument, this is your instrument. Your instrument, it's all about what is the current through the current coil, what is the potential across the potential coil. It is going to see what is across and through them. That's all. It is least bothering about what is there connected in the circuit as a load, and it doesn't see what is the load power. It is seeing only what is the voltage across me, what is the current through me. So then what is the angle between me, these two, current and potential. With that, I'm going to give the reading. That's the instrument says. Getting everyone? Understood?
Yes,
Sir,
sir.
These are known as uncompensated wattmeters. Yes.
sir, in this problem, if they give PC as 1000 ohm plus simply J1 ohm, something like that, if they give,
You need to
um,
consider. You
we
need to
should,
consider the angle of the current through the moving coil. Then the instrument reading goes with what? Instead of cos of VPC, you need to take cos of IMC. Getting everyone? All of you getting?
Yes, sir.
Because moving coil current should be in phase with the potential coil current should be in phase with the potential coil voltage. So if it is having some angle, then you need to see
Yes, sir.
only this angle. That's a fundamental.
okay, sir.
Getting
So
the
that time we should not see VPC difference, I think.
yes, what is the fundamental thing? This is the fundamental thing. That's
Yes,
a
sir.
theta average proportional
Current
to ohm.
sensing.
Current phase angle difference between fixed coil and moving coil. You have to play only with respect to the current. Getting Dhanvasha?
Okay, sir, getting, sir.
Then VPC and IPC won't be in phase.
Yes, sir.
When VPC, IPC not in phase, for the cos of for meter reading, you take cos of angle between IPC and getting my
ICC.
point? IPC and ICC. Understood?
Okay, sir. So
Don't
only
take
if they are equal,
VPC.
we should take
Yes.
VPCs. Okay.
Yes.
Only if they
Yes,
are,
yes. Only when
okay.
PC current is in phase with the VPC, then we have to take it. Angle of VPC becomes angle of IPC. Understood?
Okay, sir.
Better you remember angle of IPC always in reading instead of VPC. You will commit a mistake. Better go for angle of IPC. If VPC, IPC in phase with the VPC, then you will get same angle automatically. Getting everyone?
Yes, sir.
Yes, sir.
Okay,
Yes,
better.
sir.
You take angle of IPC
Yes, sir.
with ICC. That's a power factor. It is sensing. So that instrument is not seeing the power factor of the load. Instrument is seeing the power factor of its own coils. Understood?
Okay, sir.
Okay.
It's a pressure coil
Yes,
current
sir.
angle and current coil current angle. Only it sees. At least bothers about what is up across your load. Understood?
Yes, sir.
Yes.
All of you getting?
Yes, sir.
That's how it works. So with this, we'll conclude this session. So tomorrow, 1 minute. Okay. So tomorrow we'll see how to make a compensation. What is the time now? Okay, we'll complete this. Compensated wattmeter. Let me complete this alone. Tomorrow we'll see three-phase power measurement. Compensated wattmeter. This is going to give you 100% accurate reading.
Sir,
Yes.
sir, wattmeter reads the average power only, no, sir?
Wattmeter reads. Wattmeter reads.
Average.
This is your reading. Getting? Monopriya?
Yes, sir. Yes, sir.
That's why I'm repeating. It is not seeing what is across your load. What is the potential across the potential coil? What is the current through the current coil? And what is the angle difference, phase angle difference between pressure coil current and current coil current? That's what the instrument is concerned about. Understood?
Okay,
Getting?
sir.
That is a reading. That is a measured value, Monopriya. Understood?
So it won't be a average power, sir.
Yes, load power is, it is average only. We wanted to make it closer to that average power delivered to the load only. Our goal is to find the power across the load. That's our job. That's why we are
Okay,
connecting the instrument to the circuit. So the
okay, sir.
actual power is delivered to the load is our true value, because any instrument always will lag or lead behind your true value reading. The measured value may be greater or lesser, correct? The moment you connect instrument, always there is a
Okay,
loading
sir.
effect. Understood? Yes,
Yes, sir.
Monopriya, there is a loading effect. Either in the current
Yes, sir.
coil setup, we have a loading effect, or we have a loading effect in the potential coil setup. Understood?
Yes, sir.
Therefore, instrument reading, always treat the instrument reading as a faulty one. Okay, but it can be proportional to the average as per the proof given earlier. What is the proof given earlier? Understood?
Yes, sir. Okay, sir.
This is a proof given earlier, right?
Yes,
Getting?
sir.
What is the condition for this? Theta average is proportional to what? Power average. That's where the question is coming. Getting? It is
Yes,
reading
sir.
average power or not? It is reading average power or not?
Close to that, sir.
It is reading average power, right? But how to make
Yes,
it
sir.
okay equal to the, this is sensing the power, but how to make the instrument to see exactly the same average power of the load? You have to give the current coil current exactly the same current. Okay, potential coil voltage exactly the same voltage. This should be the load current. This should be the load voltage. Then you will get the load power. Then you will get average. Understood? Then the deflection will
Okay,
be
sir.
proportional to the load average power. Understood? So it is our
Yes, sir.
job to sense the load voltage as it is across the pressure coil and load current as it is through the current coil. If any fault in that, instrument reading will be different. Understood?
Okay, sir.
All of you getting the point?
Yes.
Yes. Then, so let us
Yes,
compensate.
sir.
Yes, sir.
So for this error, we are going to compensate the instrument. Then the instrument becomes a compensated wattmeter. We'll see how to compensate it. Let this is my current coil. This is your load. This is your load current, load voltage. The potential coil is sensing the load voltage. No fault with the pressure coil or potential coil. That shows apply. Tell me who is fault, current coil or pressure coil? Who is fault now?
Current coil, sir.
All of you?
Current coil, sir.
Current coil is making a fault. Why current coil is making a fault? What is the current through the current coil now?
IPC plus
IPC
IL.
plus IL.
So this is your IPC. If I make the connection here, what is the current through this? IPC plus what? ICC. That's a current, sorry, high load. Understood? Correct?
Yes, sir.
That is a current. So the instrument is going to read what? Instrument is going to read more
Extra
because
current.
of the pressure coil current. Understood?
Yes, sir.
Then this is my current coil winding. Tell me what is the current through that? Shortly. Tell me what is the current through this? Part of the current coil. What is the current through this? ICC plus, sorry, I load plus IPC. Understood? What is the current coil sensing? It is sensing I load current plus what? I pressure coil current it is sensing. Yes or no?
Yes, sir.
Okay. Now,
Yes, sir.
this is where my pressure coil is there. This is a connection. This is my load. This is my load current. This is my pressure coil current. Now let me do one thing. Tell me what will happen now. Yes, what will happen now? One minute. Hope you understand what I'm doing. I'm giving you a new winding. Along with the current coil, current coil has a 2-turn means I'm going to have a new winding, but it is in opposite sense. So this is your current. What is this current? What is this current anyway? This current is your pressure coil current. Now this winding, the new winding is going to carry the pressure coil current. Earlier the current coil is producing a flux. Earlier, what is the current through the current coil? Current through the current coil, tell me. Load current plus pressure coil
IPC.
current.
IPC.
Now I'm connecting, along with the current coil, I'm connecting a compensating winding. It is called compensation winding. I'm giving you a compensation winding. So tell me what's a current through the compensation winding? That is pressure coil current. Understood? Yes or no? Yes or no?
Yes, sir.
Yes, sir.
Now tell me how the poles are produced for the current coil current. As per the direction of the current, this is the direction of the current. This is the direction of the current. How the poles will be produced by the current coil current? This is the direction of the current, correct? Then this will be
Yes.
north and this will be south. And
Right.
tell me how the poles will be produced for the pressure coil current as per the winding sense.
Same
As per the
direction.
winding. Same, right?
Yes, sir.
Same or different?
Same, sir.
Earlier, north and south. Now also it is. Now change the winding sense. Yes, winding sense has to be same. Current direction is opposite. Yes. Change it. Change it means then let me make the winding this way. Now, yes. See the direction of the current. Pressure coil current direction. Yes. Yes. This is your direction of the current. This is the direction of the current. Yes, it's down. It is down. Tell me how the poles will be created now. Yes. It's down current. Yes or no?
Opposite.
Then opposite. Who is north? Who is
Yes, sir.
south?
Right side is north. Yes, yes.
Okay. Now come to the point. This is going to make a flex north and south. Okay. Right. This way. Right. What is it flex? It is going to make a flex corresponding to the load current and flex corresponding to what? Plus pressure coil current. But this one is going to produce only flex corresponding to what? Pressure coil. But this is the earlier net flex in the current coil. Now this is the opposite flex created by the compensating coil. So what is the total flex in the current coil then? The total flux in the current coil, phi L
5L.
plus phi PC minus phi PC, because you are creating an opposite flux only corresponding to the pressure coil current flux. Getting? All of you getting?
Yes, sir.
All of you getting this point?
Yes, sir.
Yes.
The point is this. Earlier, the current coil carries extra current of the pressure coil. Due to that, it is producing some extra flux. But if I add a compensatory winding, that is wound in such a way that that is going to produce a opposite flux, but that is only corresponding to the pressure coil current. Therefore, it is going to cancel the earlier flux produced by current coil due to the pressure coil current going through that. Understood? All of you getting?
Yes, sir.
Yes, sir.
All of you getting this?
Sir,
Yes, Dhanvarsha.
but in the diagram that is drawn in the orange color, like how IL plus IPC is coming, sir? Because it's
This is
the
your tapping, right? What is this current, Dhanvarsha?
IL, sir.
What is this current, Dhanvarsha? What is this current? Where it is connected?
Okay, sir, IPC. Oh, I got confused by the direction. Okay,
Understood
sir.
now?
Yes, sir, understood.
You have to pass the current IPC through the compensatory winding.
Okay,
The
okay, sir.
tapping is still here. Getting?
Yes, sir. Okay, sir.
The tapping is still here. What is this current? Pressure coil current. And what is this current? Load current.
Okay.
Then you take the compensatory winding. Getting?
Yes,
Getting?
sir. Yes, sir. Now
Then
getting clear.
make the connection. Easy, everyone? All of
Yes.
you getting?
Yes, sir.
Yes, with the compensation winding. So compensation winding senses only what current? The pressure coil current, and cancels only the flux due to the pressure coil current, and therefore the net flux in the current coil is only due to the load current, not due to the net flux is only due to what? Load current. That's a IL flux only. Understood? Load flux only.
Yes.
Load current flux only sets. So therefore, your pressure coil already sensing the voltage perfectly. Now the current coil sensing the current perfectly. Then what is the percentage error? Brought down to 0. There won't be any error due to this connection. Yes, you need a compensatory winding. Okay. Getting everyone?
Yes, sir.
Okay. Compensation winding. Let us check whether this compensation is enough even under low power factor condition. So then the instrument is known as low power factor wattmeter. What is the low power factor? LPF wattmeter. We'll see. Okay. Usually this compensation will work there also. Okay. We'll see perfect compensation can be done under the low power factor power measurement. Okay. Low power factor power measurement when the power factor is 0.1. Whether still accurate reading can be done or not. Okay, that's a low power factor power measurement. LPF wattmeter they will say. So that is well compensated. Okay, even it can read, okay, when the power factor is less. Okay, getting everyone? Following right?
Yes, sir.
So we'll talk about this LPF wattmeter in the next class. So with this, let us conclude. So the instrument is completely compensated now, but what connection we preferred here is we have to pass the pressure coil current. Okay, this connection we don't prefer. This connection we don't prefer. This connection we prefer with compensation winding, because the pressure coil current has to pass through the current coil, then compensation has to be done. So with compensation winding, connection 2 is always preferred. Getting everyone?
Yes, sir.
Yes, sir.
Okay, yes.
Any compensation for connection 1, sir?
No compensation can be done for connection 1.
Okay, sir.
You have to lose voltage. What is committing mistake in connection 1, Monopriya? Current coil voltage. How to compensate for the current coil voltage? Getting?
Yes, sir.
Because in pressure coil, you get current coil voltage as an extra in connection 1. So compensation not easy in connection 1. Cannot be done. So connection 2 compensation can be done with the compensatory winding. That is wound or can be same winding sense, but the current is in the opposite direction Ultimately, the goal is to cancel the pressure coil flux existing in the current coil. That's all. Getting everyone? What is the point? The compensation
Yes, sir.
winding sensing the current through the pressure coil simply cancels the pressure coil flux which is created by the current coil. That's all. Understood? Understood?
Yes, sir.
What is the only condition?
Yes, sir.
The compensation winding number of turns and current coil winding number of turns should be identical. Then only same MMF due to them, same fluxes due to them, perfect compensation will take place. Understood? Getting?
Yes, sir.
Yes, sir.
So number of turns
Sir.
of compensation winding must be identical to number of turns of current coil
Current coil winding.
for perfect compensation. Understood? Understood everyone?
Yes, sir.
Okay. Yes.
Last point, can you repeat, sir?
Number of turns, sir.
Yes, sir.
Okay. Compensation winding is producing a flux, okay, in opposite direction to the flux produced by current coil due to that component, current pressure coil current alone. Current coil is producing one flux, right? Monopriya?
Yes,
That
sir.
is producing two components. Current coil is having two currents. One is a load current, another one is what? Pressure coil current. So therefore,
Yes, sir.
what is unnecessary? The pressure coil current flux is
Pressure coil.
unnecessary in the current coil. That alone should be cancelled by connecting what? Compensation winding. So it can be having same winding sense, but the flux should be produced in the opposite direction. So that both 5 PCs are getting cancelled out. 5 PC, one 5 PC produced by current coil, another 5 PC produced by what? Compensatory coil. Got it?
Okay, sir.
They cancel each other. That's how the current should exist in the compensation winding. Understood?
So the number of turns in current coil and pressure coil
That
should
should
be
be
same, sir.
identical. Because then only they will produce same MMF, right?
Okay, sir. Already you said N2 must be greater than N1.
Now that
It must
N2
not
is a
be.
moving coil, not compensatory coil.
Okay, sir. Okay, sir. Okay, sir. Okay,
Getting
sir.
Monopriya. Now,
Yes, sir. Got it.
actually, already we have only two windings. Now only we brought the third winding. Understood?
Okay, sir. Okay, sir.
Third
Understood.
winding is compensation winding. Understood?
Yes, sir. Good, sir.
That is having identical number of turns, okay, with your current coil. It is also on the same core of your current coil. Wherever you have a current coil, there it is wound, okay, maybe with the same winding sense, but sensing the opposite current. So it is cancelling that extra flux produced by current coil. Understood?
Yes, sir. Got it, sir.
Okay, yes. Any other doubts? The instrument is ideal after getting the compensation winding. So compensated wattmeter reads 100% accurate value of the power to be measured, average power of the load to be measured. Easy everyone? Yes.
Yes, sir.
Let me check one problem. I think I have added with that. I'll give that as a practice problem. You try this. Okay. This one only. Can you answer this? 1 mark only. Gate 2014. But that will conclude. So it's compensated for low power factor. Yes, again there will be a compensatory winding. This itself will take care automatically. This itself is sometimes known as a LPF wattmeter. There is a reason, we'll talk about it. So power factor is given 0.2. 3 voltage settings 300, 150 and 75. Already the idea is given how we can go for multiple settings. Accordingly, the connection is made with a V. Okay, voltage selection is made. Either you can connect that wire to 75 volt position, 150 volt position or 300 volt position. Or it may be a setting you have to choose. Okay, a normal wiring is done. You have to choose a setting. Okay, 75, 150 or 300. And two current setting is also given, 5 amps and 10 amps. That's good then. Two current settings, 3 voltage settings. The full scale reading is 150. The full scale reading is 150. What is it 150? What is that full
Watts.
scale reading is 150?
Watt,
Full scale
Watts, sir?
powers, watts.
watts, I think.
Tell me what is the maximum current?
10 amps.
What is the maximum voltage?
300.
What is the power
300.
factor? 10 into 300 into 0.2. Tell me, that's the maximum power you can measure with the instrument. 10 into 300 into 0.2. 10 into 0.2 is 2. 2 into 300?
600 we get.
600, sir.
But we can't measure. But he is saying the full scale reading is 150. Okay.
Yes,
The full
sir.
scale reading is 150 means then you need to multiply with the corresponding multiplication factor. Okay. Problem is for that only. That's fine then. Understood? Getting? All of you getting?
Yes, sir.
Yes,
Yes,
sir.
sir.
Into 4.
The full scale reading is only 150 watts. Uniform scale. This is 0 watts. That's all. That's what the instrument is. If the wattmeter is used in 150 volt voltage setting, so 0 to 150 volt is the potential coil voltage. That's a potential coil setting. 10 amps current setting, current coil 0 to 10 amps. Current coil can carry any current from 0 to 10 amps. The multiplying factor of the wattmeters and power factor is already given. Tell me what maximum power we can measure. 150
100 watt.
into 10 amps into 0.2 only we can measure. Understood?
Yes, sir.
Okay, okay, sir.
Tell me how much you can measure. 300?
300, sir.
300.
Yes, sir. 300 watts, sir.
Then what is your scale there?
150
150
How to get 300 then?
into 2, sir.
into 2.
That's all. Getting? All of you getting?
Yes, sir.
That's all. So multiply your reading with 2. Whatever the reading the pointer can read, the pointer of the instrument can read, for example, 80 watts. What is your reading actually? The measured value becomes your
80.
multiplication factor into 80. What is the reading?
160.
That's how it goes. Understood?
Yes, sir.
All of you getting?
Yes, sir.
Yes, sir.
That's all. Okay. So with this, we'll conclude the day. So tomorrow we'll cover the 3-phase power measurement by using single watt meter, 2 watt meter, and 3 watt meter methods. Okay.
Yes.
Sir,
Yes, Rahul.
what was the last point, sir? Measured 160 watts.
Measured
how did you
value
get?
is equal to multiplying factor into the reading of the instrument. What is
If
the
it is
reading?
80 watts, then
80 watts. It shows 80
Okay.
watts in watt scale, 150 watt scale. Is that your
Okay.
measured value? Why you are calculating multiplying factor?
Okay, sir. Sir,
Okay, your
how I
setting is
thought.
what? 0 to 150, right?
Yes, sir.
Then 0 to 10. Then what is the maximum we can measure?
Mhm.
In this setting, the reading is 80 watts, Rahul. I'm giving 150
Yes,
volt
sir.
setting, 10 amp setting. In this setting, the meter reads 80 watts. What is the measured value then? What is the maximum you can measure? 300. But what is your scale?
100.
150. Then what is the multiplying
150.
power? 2. Instead of asking multiplying factor, I will say at this scale, the meter reads what? 80 watts. Then what is the measured value? Then I will ask. I'll confuse you by giving the meter reads 80 watts. Then what is the measured value? I will ask. Yes or no?
Okay.
Are you getting?
Yes, sir. Sir, but yes, sir. Why are we going to full scale deflection, sir? Then?
That is
Why
your setting. Okay.
300 watts?
See, fine then. So, see, you have a volt setting, you have a current setting, correct?
Yes, sir.
It
Yes,
means
sir.
that your load voltage can be maximum of 150. Your load current can be maximum of what? 10 amps. Are you getting?
Yes, sir.
With that, what is in
Yes,
that
sir.
range? What is the power you are measuring? See, you are measuring power means you need to get 0 to what? See, when you are measuring
150.
voltage, 0 to VFSD, measuring current 0 to IFSD. When you are measuring power,
Yes,
0
sir.
to power FSD you need. Yes or no?
Yes, sir.
How to get this?
Yes, sir.
Voltage you need full scale,
Power
current you
FS.
need full scale, power
Yes,
factor
sir.
you need, all are given. That means that you are
Yes,
measuring
sir.
0 to 300 watts. So this is your range of measurement for the setting. Then,
Sir.
but the instrument scale is
Okay.
150. But how to get 300? Multiply every reading by 2. Understood?
Yes, sir.
Still
But
not
sir, they're
convinced?
using the same scale. Yes, sir. I'm not convinced, sir.
Is it okay now?
Actually, sir, actually they're using 3 voltage settings, right?
Yes. But
3
what is
voltage
set
settings
finally?
for the same
Where
scale.
it got set
For the
finally?
same scale.
Where it got set?
150 volts.
Potential coil is set to 150 because I said potential coil is like a voltmeter. So it is sensing 150 volt load voltage. Current coil,
Yes, sir.
10 amps. It can sense how much load current?
Yes.
10 amps. Power factor of the load is given.
10.
Okay. Power factor is given.
Okay.
How much
Yeah, that's
maximum you can
okay.
measure under the setting? That's a full scale deflection power.
Yes, sir.
Then you are getting 300 watts. But what is the scale available as FSD? 150.
Yes, sir.
Then 300 by 150. That's a multiplying power. Okay.
Sir,
Yes, Dhanvarsha.
Sir,
should the true value equal to multiplying factor into measured value, no, sir? Because 80 watt we are measuring, true value only is 160, like that.
Okay, what is the reading of the instrument finally? Actually, I am not talking about the true value, Dhanvarsha, because I am not talking about load power now. I am saying instrument reading is 80 watts. Then what is
Okay,
your
sir.
actual measured value? Because the pointer is deflecting to 80 watt position. Is
Okay,
that
sir.
your reading under the setting?
No, sir, actually 160.
Correct? Because 80 watts on what scale?
150 watt scale.
Then what is your range setting?
300
Or
watt. Okay, sir.
300. Then every reading has to be multiplied by 2, right?
Yes, sir. Yes, sir.
Understood, everyone?
Okay, sir.
Yes, sir.
Okay, now I am giving you a simple
sir.
example. Yes.
Sir,
Yes.
sir, how
Sir,
we are
one
getting
small
that
doubt,
80
sir.
watts? Sir?
Okay, one by one. Yes, Monopriya.
Sir, how we are getting that 80 watt?
I'm saying my statement is this, Monopriya. So
Okay,
an
okay.
instrument having this spec with a wattmeter setting on voltage setting of 150, current setting of 10 amps, the instrument is reading 80 watts.
Okay, sir. For example, you are taking, sir.
Yes, that's a new example
Okay,
I'm
sir.
saying.
Okay, sir. Okay, sir.
That is the last problem is over. You got the multiplying factor, you completed the problem. I'm adding another one. I am saying
Okay, sir.
that under the setting with the 150 watt scale, okay, the full scale reading is 150. So it is meaning that 150 watts. So under the setting, my instrument reads 80 watts means what is my reading of what is the measured value?
Okay, sir.
Or what is the true value I am measuring? Assuming the instrument is otherwise accurate 100%. Getting
Okay,
everyone?
sir. Got it, sir.
Yes, Rahul now.
Yes, sir. Actually,
Still?
I think I'm getting some clarity, sir.
Got it
Uh,
now? Yes or no?
yes, actually,
It's like in CRO and all, we will use multiplying
Very
factor
simple.
for
I
setting.
have the instrument, Rahul. Very
sir,
simple.
my doubt is for each setting, the scale is same or different, sir?
I have my instrument, Rahul. This
Okay,
is
sir.
calibrated to maximum of 150 watts. That's all. Getting?
Okay.
Getting?
Okay, sir. Got it.
150 only.
Yes, sir.
Now this is my instrument.
Okay, then for each
This
setting,
is
there
my
will be
instrument.
different
I have
multiplication
150
factor,
only
right?
setting. My scale is calibrated from 0 to
Okay, sir.
150 only. That's all. Okay? Understood? Now
Yes,
I'm
sir.
going for
Yes, sir.
a 0 to, what are the settings? 300. Let me take. I'm going for 0 to 300 volt. My potential coil set to 300 volt setting. My current is having only 2, right? 10 or 5. I'm going for
5
5.
amps.
So let me go for 0 to 5. Okay. Now,
Okay, sir.
assuming it's a UPF wattmeter. I am
Hmm.
saying UPF wattmeter. What is that UPF wattmeter? Unity power factor wattmeter. What is the power factor
One.
now? LPF means power factor must be given. UPF means power factor need not to be given. That's very indirect statement. So UPF wattmeter
Okay.
means how much you can measure? You need 0 to PFSD. What is the power you can measure? Unity power factor. Unity power factor means what is the power? VI cos phi. What is cos phi now?
1.
1. Tell
1.
me how much maximum you can measure? 0 to 300 into 5 you can measure. How much?
1500.
1500 watts you can measure. But what is your scale now?
150.
Then reading has to be multiplied by what?
So into 10.
Measured value equal to
Into 10. Okay, sir.
reading
Got it, sir.
into 1500 by 150. That's your multiplying power, or multiply by what?
Yes, sir.
You have to multiply by what? Understood?
Yes, sir. Got it.
Okay,
Yes,
now if the instrument reads, in this scale, if the instrument is reading 30 watts, if it is reading 30 watts, what is the measured value? 30 watts into
300.
10. How much? 300 watts is the measured
300 watts.
value with this setting. Understood? All of you getting?
Yes, sir.
Yes, yes, yes.
That's all.
Yes, I'm getting, sir.
That's a practical insight. Sometimes they will ask for division. Okay, to what division it will deflect? They will say 150 or 50 division wattmeter, they will say. Then they will simply ask you to what division it will deflect, where the pointer will be. Okay, at what position the pointer will be. Something like that they will ask. Understood? All of you clear about
Yes,
this?
sir.
Yes, sir.
Okay, so thank you everyone. We'll meet tomorrow. Okay,
Yes.
fine.
Thank you, sir.
Yes.
Sir, today signal, sir. I mean,
Yes,
communication,
as
sir.
usual, same timing,
At 6:30.
6:30.
Yeah, okay,
Yes,
sir.
yes. Okay.
Thank you, sir.
Yes, fine, Rahul.
Thank you.
Thank you, sir.
Welcome everyone.
Thank you, sir.
Welcome, Monopriya.